here. It is April 29th, going into the 30th, 2020. And yeah, I'm going to come at you with a video. So, just like normal, guys, we'll start off with the Schumann stuff, what's going on with that. But before we do start that, keep in mind tonight and into the morning is when the closest that big asteroid is actually going to be passing by us. I think we have to keep in mind that thing really never was already past Earth's orbit. So it wasn't like going to cross over our orbital path. It was already outside of that. We were saying it wasn't going to hit anyway. We know that. If it was, it'd been a lot bigger news. Just letting you know. But I did want to mention that because it is interesting. You guys go check it out on some of the websites. There's lots of articles, lots of news on it. Kind of rightfully so. It was a pretty large one, and it did come within inside 4 million miles. So, that is what they consider, in the range of a near-Earth object. So, even though 4 million miles to us really doesn't really seem like, that close, but it is when we're talking about the vastness of space. But, so we're going to talk about Schumann here real quick. Something else, guys, I've been noticing lots of patterns in this thing, and I've been talking about the pulses like I was in my previous video, and it's continuing like that. Not to mention that the spikes that we're seeing are very similar to one another. They're like taking the same shape, maybe not like the same size, but just look at these two right here. Let me get out my draw tool real quick. Sorry about that. Should have had that already out there. So I'm going to zoom in here and explain to you what I'm talking about. Now, this spike that happened back here, you see how it just abruptly started. And I've talked about that before. That's why you get that hard straight line. It didn't like fade in and then fade out, right? It kind of faded out, but it didn't fade in. It was just like, bam, it started. And then, over here, same exact thing. So if you look at these two spikes, if you were to like shrink them down, this bigger one, and look at it side by side, they would look almost identical. This one faded off pretty much in the same fashion as this one did. Okay, you guys see what I'm seeing there? I hope you can. But again, kind of the same drop off. I mean, it's really kind of strange. Not to mention that, again, guys, the pulse. Look, this thing is pulsing still. At least starting and stopping if it's not a pulse. So again, we have to wonder why that's happening. Now, the rest of it, guys, here is the same as what it has been. There's really not much more of a change. So if you guys have been experiencing, at least, yesterday or last evening, if you had a hard time sleeping, if you had ringing in your ears really bad, or any of those kinds of things, this could have been the reason. Now again, the code line's still there, still continuing. This line here, okay. So I just wanted to give you a little update on that. But listen, I mean, that pulse thing is still going on. We're still having a considerable amount of spikes, and they seem to be resembling each other. It's just kind of strange when it does that. It's been my experience, at least through my lifetime, that when stuff is resembling each other time after time after time, once a pattern's established, it's hard to deny that that's what's actually happening. So that is something that we're seeing. Just the observation. You guys run with that, whatever you guys think is going on with that. I would love to hear what you guys have to say about that. It's pretty cool, in my opinion, even though we don't know exactly what's going on there. But, we'll take that for whatever it's worth. And, yeah, so we'll move on. Okay, guys, we're going to talk about Comet Swan. And before we do that, Comet Atlas, guys, is pretty much just broken apart. They don't even think hardly any of it, if any at all, is going to even make it to the sun at this point. So that is pretty much a non-story anymore. We're not going to be able to see it with our naked eye. You could probably find find it with a telescope or maybe some real powerful binoculars, maybe. Um, but now we need to talk about this comet. This is Comet Swan, and what you're seeing is a black and white version. It's a little movie that this is over at spaceweather.com. I would encourage you guys to go over and check them out once again. But you can see where this is the gases that are coming off of it, and yeah, it's pretty cool. Now, what we're going to do is I'm going to go back to the main page here, and then we'll talk a little bit more about what's going on with this. Okay, guys, it is visible with the naked eye. Okay, I think it's sitting at like a 5.5 magnitude. The lower the magnitude that we're talking about, the brighter it is. Now, it would look kind of fuzzy to our naked eye, and you would pretty much have to know where you're looking. Plus, really have some decent eyesight, because this is one of those things that's just barely in the realm of us being able to see it. It had to be probably a pretty clear night. You would have to go out somewhere where it was pretty dark, out in the country and stuff. If you live in the city, you're pretty much out of luck right now with that. You could get your telescope out and probably find it, again, if you knew where to look. Now, this right here is showing you exactly what the threshold is for the naked eye. So right around 6 is when they say, hey, you can probably start seeing it. But it's like at a 5.5, so it's just like barely in that. Now, there's some different ideas on whether or not this is going to get brighter or not. And a lot of things, have to do with that. And I think Comet Atlas, what it taught us, that those of us that didn't know a whole lot about the comet situation, is the fact that it is so volatile about, what's actually going to happen. Sometimes they just don't know. Once it starts getting closer to the sun, interacting more with the solar wind, lots of things can happen. And that's exactly what we've seen with Comet Atlas. They can predict all they want, but we don't know exactly until it actually makes this loop around. Again, they didn't discover this one until 2020. So that's why it has that designation. So keep that in mind, guys. Just get on some star charts. They're easy to find online. They're free. And you can go look on that to tell you where to look at from your location where you're at to find this thing. And it would be different if you're sitting, in different places in the country or around the world. I know we have a lot of listeners from around the world too, Australia, England, New Zealand, all over the place. I've even got some people in China that's emailed me, Japan, all that kind of stuff. So depending on where you're at, it'll matter what direction you look. So, but I think this is a pretty neat story to follow. Do I think this is going to do anything to us? No, I don't. It's just going to be one of those things we look at, and there it is. Very interesting. I remember being a kid watching Hale-Bopp and Halley's Comet when it came through the last time. That was a neat thing for me anyway. And I would encourage you guys, especially with our world being on lockdown right now, take your kids out. Do something neat with that. Take advantage of the time we're being stuck in the house with each other. I know it can be stressful sometimes, but take advantage of that. Get closer to each other. Go out and do stuff like that. Create some memories. I think this is a good chance to do that. So, hey guys, okay, got you over here at an illustration of the sun, and what are we looking at? Well, we got another sunspot that popped up today. Okay, it is from the new solar cycle. Now, the one that was down here was the one that gave us that little CME yesterday. Okay, and once it did that, it went completely away. It lost every characteristic it ever had of being a sunspot. So if you guys remember, that is the one that popped up real fast right here. Once we started seeing a little bit of activity, it was like there in like 6 hours. So this kind of shows that they can come and go very, very quickly, especially if they flare or have a CME. So, and that's what happened to this one. It wasn't a big one anyway. But this one here, guys, it started, I think it might have even started off of the side of the sun before we could even see it. So, it's hanging around for a minute. there's a chance that we've seen them go around to, make, I don't know, 2, 3, sometimes 4 full rotations around. Okay, and some of them, I think they do keep their number designation if they're able to tell that that's still the same sunspot. So with that being said, we're still in solar minimum. Okay, but now we've had, at least here in the past week, two sunspots from the new solar cycle. This bigger one's from the old one. So we are starting to ramp up, and this is the most dangerous time that we need to pay attention, because once these things start popping up, they'll start throwing more and more flares and CMEs at us, while our magnetic field is roughly about 20% weaker than what it was. So until we can get our magnetic field built back up, we really have to pay attention to this. So, and even after that, because, big flares can do big things no matter how strong your magnetic field is. Okay, guys, I got you here on the 29th. And what you're seeing is that CME I showed you guys earlier. But what we're seeing, guys, is a little bit of what they call, well, I'm not sure if they would classify this as that, but there's something called an interplanetary shock wave. What that is when you have charged particles moving at a certain speed, aka solar wind, okay, and you have faster solar wind or charged particles behind it, and when it catches up to the slower moving ones, they have a reaction with each other, and it causes what they call an interplanetary shock wave, okay, and basically it's the magnetic fields of those charged particles interacting with each other, okay. Very seldom do they actually physically crash in, okay, because their fields start reacting and they push away from each other. So when that happens, they discovered that it actually sends out a little bit of, like a little smaller blast of more intense energy, okay, at a basic level. Okay, they were able to capture this last year for the first time. And, with some of the tools and newer tools and technology they got, they actually caught this. And it does happen quite often, especially when we're talking about solar wind, just pure solar wind, not CMEs or solar flares, but that would also come into play too. If a CME was launched or a solar flare and it met up with some slower moving material, there you go. You have that reaction still. But they were able to catch it last year, which I thought was pretty cool. But if you look close here, guys, you'll see that the material here is moving pretty much, or the energy here is moving pretty much at a steady speed, and then the sun has another little bit of a temper tantrum, right? And it kind of starts right here, and you'll see it move a little faster than the rest of it around it. We'll watch it one more time here. See that? Okay, so when that happened, most likely there was some sort of an interplanetary shock wave, which we probably couldn't pick it up very well because of its location. It's still real close to the sun. So anyway, something else I want to point out here, guys. We see a couple little jets of energy come off right here too. Watch where I just marked that. There on the bottom, there on the top, what that means. And then you've seen that, after you've seen these two little, what I would call jet puffs or whatever, then that CME comes off. There, and boom, okay? What was happening was we couldn't see behind that occulter, okay? Remember, this is our view from Earth. And this black disc is an occulter on the camera, blocks out most of the light, so we can even get a capture. The surface of the sun is kind of like this. It would be centered. That's off center a little bit. But so that was actually happening behind that occulter. These jets were going out too behind that occulter. We couldn't see behind that. So what that means is that most likely some of that energy is coming at us, because that, the occulter is right in front of us, but it's between us and the sun. So if something's coming right at this occulter, we're not going to see it. Just letting you know. So that's why we look at those things. Plus we go look at stereo A, and it kind of confirms it. So I'll show you the latest captures from today. This is actually kind of odd looking still. Yeah, not much to say there, other than that's just the end of that CME coming on out, and it does look to be possibly coming our way a little bit. We can't really tell because of the view. But let me show you stereo A. Okay, guys, this is stereo A. Now, this is the side view that we talk about. Okay, this is the satellite, and Earth's kind of like right here. All right, that's our viewpoint. So if you look over here on the red, you're not going to see a whole lot on this day, but you are seeing a little bit of a brightening. Okay, that's when all this stuff started, was on the 28th. So we'll go to the next day. Watch what happens. Okay, it's clearly a CME. All right, now it does look like it could be coming our direction. Don't know for sure yet. But, the CME tracker is saying that it is. And I showed that to you yesterday. Guys, go back and watch my previous video. You'll be able to see it. Or go to the CME tracker yourself and look. And they'll change the CME tracker if there's another one. They will. That's the only time that thing updates, is when there is a CME. So, but what I want to point out is, at the end of this, that little ball that appears is kind of odd. Little dark area there on the end. Again, we're seeing this shape of a CME quite often lately. I don't know what's causing it, but it's almost like plasma balls. It really is. That's what it looks like. I ain't saying that that's what it is, but it could, that's plasma coming off the sun. So if it's all, concentrated, I guess it could be. But as you're looking at that, that's something we don't typically see a whole lot of. And if you go over here on the red view, it actually gives you kind of a better idea. You can see where it's spread out, and then you still got this base material, I guess, if you want to call it that. And you can see even as it's going through this brighter area of the sun, of the energy coming off the sun, you can still see some left behind there. So, I really don't know what to make of that part of it, but it does look like this stuff is going to come at us. We should see some space weather from this. So, okay, guys, this is over at space weather. And as you can see, guys, this is the solar X-ray flux. You can see how we had a steady increase. Okay, and that would be exactly what we would expect from those sunspots being there. Okay, we had this little spike yesterday when that CME started, or flaring, whatever. And then it kind of it was rising, and then same kind of thing happened again. And it looks like it might be on the uptick right now as we speak, right here. Okay, not to say that it is. Don't know for sure if anything's going on right now. But if we look at this, we can scroll on down. You can see, guys, where the solar wind like completely dropped out. I'm talking low solar wind. Okay, we don't typically see this thing get below 300, and it's showing readings of like 260. That's slow, guys. Okay, here's the range here. It's pretty slow. Not to mention that the density doesn't look like it was doing much of anything either. Remember, the range here is 0 to 1. Usually, it's, what we see is 0 to 1, and then 1 to 10, and then 10 to 100. Okay? Right now, this is showing 0 to 1. So, in other words, the density isn't getting over 1. That's really low, guys. Okay? Not to mention the solar wind dropped out. So it's almost like we had a really calm time here going on. What for, don't know. But, sometimes we get a flushing effect. That's when we get like a period of time where we have fast solar wind. And what it does is it kind of sweeps away some of the more dense particles, pushes them on out in space. So sometimes after a solar wind event, we'll see stuff like this, okay, or a big CME or something like that. It'll flush all that stuff out of here. It's good and bad, but we'll take it, I guess. But you can see how the geomagnetic activity isn't really doing anything. It's calm. Matter of fact, it's too calm in my opinion. When it starts getting that low for an extended period of time, we got to start paying attention to cosmic rays. So that's that's why we don't want it low for an extended period of time. But guys, I'm going to end it there. I'm going to try to do another video for you tomorrow. Everybody stay safe, stay positive. Lean on each other. We'll make it through all this junk everybody's going through right now. Try to stay grounded as much as you can, but keep your skeptical hat on too. Be open-minded a little bit, but also trust your gut. So, anyway, guys, God bless. Yeshua saves, and you can drink this Kool-Aid.